Okay, in this this lecture, I want to talk about integration by parts. And so, actually, in this particular video, I'm just going to introduce integration by parts and maybe do one example, and then I'll do another video that does a few more example problems. So let's begin with, instead of integration, let's start with taking the derivative. So if we have something like x minus 1 times e to the x, how would I take the derivative of that? So you might recognize this as a product, right? So we have, if you recall, we have f of x times g of x, and we want to take the derivative of that product. Then it's the derivative of the first function times the second function plus the first function times the derivative of the second. Although we could switch these, right? Because the commutativity of addition, it wouldn't matter which one we took the derivative of first. But the idea is we take the derivative of one of them, leave the other alone, add to that the derivative of the other one times the one that you already took the derivative of. Anyways, so that's a quick review of the product rule. So applying that here, if we take the derivative of the first, we're just left with 1 times the second function, which is e to the x, plus the first function, x minus 1 times e to the x. Now we can simplify here a little bit, right? So 1 times e to the x is e to the x, and if we distribute this e to the x here, we get plus x e to the x minus e to the x. So e to the x minus e to the x is 0, so this just simplifies to x e to the x. All right, so what does that, why would I start with the product rule if I want to talk about integration by parts? Because this might give us some insight into, if I asked you now, what is the antiderivative of x e to the x? Well, we know that because the antiderivative of the function is the function we would take the derivative of to get this function, and we just did that. So that's going to be x minus 1 times e to the x. Of course, the most general antiderivative, right? Because if I had added on any constant to this original one, we would still end up with x e to the x because the constant would disappear. What this is about, what integration by parts allows us to do, is to get this by basically working the product rule in reverse, in some sense. So I'm going to just change from f and g to u and v in order to be consistent with the notation in the book. So just real quick, let's just write that down. So if we have u of x times v of x, then what we're looking at is, same thing up here, except I'm going to call the first one u and the second one v. So we have u prime of x times v of x plus u of x times v prime of x. All right, so if I rearrange things here a little bit, let's solve for this term right here. So that means I would subtract this off of both sides, and I would get that u of x times v prime of x equals the derivative of this, u of x times v of x, minus this, right? I'm going to subtract that from both sides, so I get u prime of x, v of x. All right, why am I doing this? Well, ultimately we want to basically find the antiderivative of this in terms of these. So if I say the antiderivative of u of x, v prime of x with respect to x, all right, then that's the antiderivative of this whole side. So the derivative of u of x, v of x minus u prime of x, v of x. All right. Actually, it's, yeah, right. Taking the antiderivative of this whole thing. Okay. Now we already know that the antiderivative of a difference is the difference of the antiderivative, so I can rewrite that this way: u of x, v of x, and that's with respect to x, minus the antiderivative whoops, leave my dx out here too, right? That whole thing is what I'm taking the antiderivative of. Now I have the u prime of x, v of x, dx. But notice here, I'm taking the antiderivative of the derivative. So by the second part of the fundamental theorem of calculus, we know that just gives us back this function right here, right? That differentiation and integration are inverse operations. They undo each other. So this just gives me u of x times v of x minus u prime of x, well, the antiderivative u prime of x times v of x dx. So this is another way to find the antiderivative of something like this. All right. Again, I think there's this question of why. Why would we do this? Well, sometimes what we start off with, if you look at this x e to the x, we don't have a method right now, by hand at least, of finding that antiderivative. But this may be, if we can identify in here kind of what our u and our v prime is, then u prime times v might actually be an antiderivative. We do have a method for finding. So let's just apply this to this example up here so we can kind of see how it works. All right, I'm going to, well, let's first identify in this, I might need to go to another piece of paper, but let's first start with just writing this down here. All right, now what I need to do is identify which is u and which is v prime, because this gives me a formula. If once I've identified what u and v prime are, then if I know what u is, I can figure out u prime. If I know what v prime is, I can figure out v, because v is the antiderivative of v prime, and u prime is the derivative of u. So the first thing I'll need to do when I'm trying to apply integration by parts is identify what u and v are. Sorry, u and v prime are in the antiderivative or the integral that I'm trying to evaluate. So let's let u equal x, and we'll let v prime equal e to dx. Knowing how to choose these is something that takes some experience, but we'll be able to come up with at least some guidelines. But one reason that I'm doing this is now if I find u prime, that's just going to be 1. V is the antiderivative of e to the x, which is just e to the x. Now I could have let u be e to the x and the derivative would have been e to the x. That would have been simple. But notice here, I still will have another antiderivative to find, or an integral to evaluate here, but it's going to involve u prime and v. By letting u equal x and taking the derivative, I'm going to end up with something here, 1 times e to the x, that I know how to find the antiderivative of. So we'll see how much more I can fit on this page. This then, after we do this antiderivative will equal u times v, so that's going to be my x times e to the x minus the integral of u prime, which is 1 times e to the x, so that's just e to the x dx. All right, so now I have, that's x e to the x minus the antiderivative, which is just e to the x. All right, and then I need to add, because this is an antiderivative, I need to add on a plus c. Notice now here, if I factor out an e to the x, I'm left with what I started with up here at the top. Well, not exactly, but it's the same, right? I have the e to the x here first, but so that's generally how that works. The idea here is we have something we don't know how to find the antiderivative of, but we can reduce it to something over here, like this, that we do know how to find the antiderivative of. All right, let me just do one more example of this. I have 4 examples, I'll do it all, but I'm going to do one more on this video, and then I will do 3 more on a separate video, so the videos don't get too large or long. Okay, so let's take a look at something like the integral of x times cosine of 2x dx. Again, the first thing we want to do here is identify what u and v prime are. All right, and then from there, I can figure out what u prime and v are. Now, in general, if you have just an x hanging around, it's a good candidate for u, because once I take the derivative, I just end up with 1. All right, and then that means I'll be left with just taking the antiderivative of whatever v is because of the formula here. This is, I guess I should kind of start this. This is kind of the formula for integration by parts. This is the, ultimately, once I'm done here, once I find u and, identify u and v prime and then find u prime and v, ultimately this right here, I want it to be something that I know how to do. All right, so that's kind of the main criterion. Sometimes you're going to have to go into it, you're going to have to play with it and realize, oh, I don't know that, so I have to switch around what I called u and v prime. And we said v prime is going to be cosine of 2x. So the antiderivative, now you could use u substitution here and let u equal 2x, although u is probably not a good choice since u already is taken here. Maybe we'll let it be t, but you already know that this is 1/2 sine of 2x. You can check that, right? If you take the derivative, well, the derivative of sine is cosine. Remember, this is the chain rule. The derivative of sine is cosine. The derivative of 2x is 2. So we would get cosine 2x times 2, but then the 1/2 takes care of that too, and we just get back cosine 2x. All right, so I've got my u prime, v, and v prime. So this, remember, is going to be u times v. So I'm going to have x times 1/2 sine of 2x minus the integral of u prime times v. So that's going to be 1 times 1/2 sine x. I can bring the 1/2 out front, sine of 2x dx. All right, now this is something, similar to what I did here, this is something I know how to find the antiderivative of. So let's simplify here. X times 1/2 is just x, we could write that as x over 2 sine of 2x. The antiderivative of sine of 2x, all right, that's just, well, let's see, 1/2 times that antiderivative. Well, that's going to be, well, the derivative of negative cosine is sine. And because I have this 2x, I have to divide by 1/2. So I end up with a negative 1/2 cosine 2x. Again, you could use u substitution for that, or t substitution if you please, but I'm going to assume you know how to do that. If you're not sure, then I would recommend that you go ahead and do that. Make a substitution, let t equal 2x, and take the derivative, divide through by 2, and you'll get your 1/2. All right, let's just simplify this. Let's not forget that we do have a plus c here because this is a general antiderivative. And so we have x over 2 sine of 2x. So that will become a positive 1/4 cosine of 2x plus c. Of course, on any of these, you can always take the derivative and simplify to see if you get back what we started with. All right, so there's that one example. I'm going to go through a couple examples that are a little bit more involved in the next video.